All right, so today we're going to continue on with triangles, and we're going to prove triangles congruent a shorter way. Before we prove triangles congruent by definition of congruent triangles, meaning proving 3 pairs of congruent sides and 3 pairs of congruent angles, which is kind of tedious. So now we're going into some shortcuts. The first one is called SAS. The breakdown of that is called side angle side. So that, again, we call it SAS. So that says if 2 sides and the included angle of one triangle are congruent to the 2 sides and the included angle of a second triangle, then the 2 triangles are congruent. So we're going to look at what that looks like using our diagram. So here in my diagram, it says if side PQ, so here is side PQ, I'm going to highlight it, is congruent to WX, that's my first pair of sides. Then if my angle Q is congruent to angle X and side QS is congruent to XY, we can say the triangles are congruent by SAS. Again, that's a shortcut, meaning we have a combination of 2 pairs of sides at an angle. Now the angle is included, almost like an ice cream cone. You can see the angle is sandwiched in between the 2 pairs of sides I highlighted. All right, so let's look at what SAS could look like and what it does not look like. All right, again, what it does look like, what it does not look like. All right, I'm going to start with what it does not look like. So here is an example using 2 pairs. So I'm adding these markings. I'm making my own example. So in my first example, why would this fail SAS? So it would fail SAS because of this angle here. It is not an included angle. So it automatically fails. All right, here is my second example. Again, marking my own picture, making this example for you guys. So why does this fail? This fails on both accounts. Now they both have to make SAS work. Here, they both do not. This is a side, this is a side, this is an angle. Remember, for side, angle, side to work, we need that angle sandwiched in between the 2 sides. All right, so what side, angle, side looks like is like this. That spells out SAS, and then the second triangle must do the same. Notice they don't have to go in the same order, but they do have to have that angle in between and the sides marked off of 2 congruent sides. All right, let's look at some more examples. All right, it says state the included angle of the following sides of the given triangle. So they're telling me triangle AEB and triangle MNO. Notice there is no picture, so you should be drawing a picture. So I'm going to sketch out a picture for AEB. All right, so I'm going to highlight. Here it says AE and EB. So where they meet at is my included angle. So on this example, it is angle E. AB and EB my example in pink, you can see they meet at angle B. So what would be a common thing that happened in both those examples? Look at, if I didn't have the picture, how would I identify that included angle? So here, we repeat the letter. And here, we repeated the letter. So look at triangle MNO and try to answer those 2 questions on your own, and then check back. All right, so the first one, MN and ON, the included angle would be angle, angle N. And then the second one, here we have MO and ON, that would be angle O. Again, the letter that repeats. That's the included angle. All right, and then example 2, it says decide whether there's enough information to prove the triangles are congruent. So our goal for today is to use the shortcut. That shortcut for today is SAS. Okay, side, angle, side. Remember that we are allowed to add markings as long as we can give reason of why. All right, so let's look at the first example. Here we have those two triangles. I'm going to make these tick marks darker just so you can see them better. So here we already have a pair of sides and an angle. Is there anything I could add to my diagram? And the answer is yes. I can add a pair of tick marks here. They share that side that we talked about. So what that would look like is I could say EG is congruent to EG by reflexive. Now, looking at the triangles, now we have to determine, can I say the two triangles are congruent? So looking at this first triangle, this has SAS. This triangle also has SAS. So I could say triangle DEG is congruent to triangle FGE by SAS. You have to include how you're proving those triangles congruent because we are going to learn more shortcuts. All right, moving on to the next example. We have triangle MNO and RON. So the first thing I'm going to do is, again, darken my tick marks so you can see them. All right, so now can I add any markings? The answer is, again, yes. We have that shared common side. So I could add those tick marks there. And I'm writing Y because that's our reasoning. So that's reflexive. Now, are my triangles congruent? So look at the top one. So is that right angle sandwiched in between those two congruent sides? And the answer is no. So now I can automatically say that this fails SAS. So I'm going to say not congruent. That would be my final answer for that problem. All right, let's look. I'm going to jump down to this problem right here first. All right, is there any markings I can add to this problem? And the answer is yes, there is something I can add. The first thing I can add are these two markings here. And the reason for those markings is because those angles are vertical. They're congruent because vertical. All right, but there are no more markings I can add on this diagram. So unfortunately, the triangles are not congruent. There's not enough information to say that they are. All right, last triangle here. I like to separate them. So I'm going to separate these two triangles. So here is STU. So a tick mark goes here. Curve marking goes here. Now I'm going to draw out the other triangle. PUT. Tick mark goes here. Curve marking goes here. All right. Is there anything I can add? So this one's a little tricky. And the answer is yes, I can add something here. I'm going to highlight it on the sketched out picture and the original diagram. I hope you can see they both have TU. TU is the same length in both triangles. It is a shared side. So I can put those two tick marks there. And we can say that is by reflexive. So triangle STU is congruent to triangle PUT by SAS. All right, and we're going to finish this out by looking at a proof together. All right, so I added a lot of words on the paper. I'm not going to read them. They're tips for you to get through the proof. All right, we're going to jump right into the picture and we're going to mark up this diagram. All right, so it says C is the midpoint of NB. So I'm going to highlight that. And I'm going to highlight NB. What does that sentence give me? I know that C is the midpoint, so I know it chops it up into two equal parts. So that gives me this. I can say that, let me put it right here, NC is congruent to CB. And the reason for that is definition of midpoint. All right, the next one, we have C is the midpoint of MA. So we have this happening again. So I'm going to put two tick marks here, second pair. That's going to be MC is congruent to CA, definition of midpoint. All right, is there anything I can add outside from the given? Remember, we should be able to prove this because a proof we should be able to prove. I'm not trying to give you a trick. All right, so I can add, and I'm going to color them in, these two angles here. Now those two angles, we want to name them by using 3 letters. So that is angle NCM is congruent to angle BCA. Look, that C fell right in the middle when I named them. That's that vertex, and that is by vertical angles. So do I have enough to use my shortcut of SAS? Do I have a side, an included angle, and another side in both triangles? Yes, I do. So now we're going to fill out this proof. And so I had some questions on how we start. So the first thing we're going to do is write the given. I'm going to write only the first given in pink. I'm actually going to break it apart. So this is my favorite way to do the proof. So C is the midpoint of NB, and that's given. What did that given give us? So going back to your picture, look at your picture and what did it give me? It gave me NC is congruent to CB. And the reason we wrote that, so again, that gave that to me, that was definition of midpoint. I'm going to do the same thing again. Now I'm going to write that one I highlighted in orange. And I'm going to write C is the midpoint of NB. Again, that's given. It is okay that we break our given up. What did that given give me? It told me that MC is congruent to CA. And again, that was definition of midpoint. All right, that was all that was given in there. So now I'm going to put whatever we found outside of the given. And the last thing we found was the vertical angles. So we have angle NCM is congruent to angle BCA, and that was definition of vertical angles. Right? One more step. Because we noticed that we have our 2 pairs of sides and angle included in between, we can say that triangle NMC is congruent to triangle BAC. Again, I'm using exactly the ways written in the proof statement. And we're going to say SAS. So you can write it out as side angle side, but I like to write the shortcut. That's the most common way. And then we are done with our proof. All right, so again, I really do like to break that given up to explain what each given gives me. It gives it kind of a better flow. If not, you can write all the given together and then put those pieces after. All right, we're going to practice more of this in class. Make sure you ask any questions. See you then.